Okay, hi everybody. So for our second lesson this week, we are going to continue talking about the unit circle, and today our focus is going to be on evaluating trig functions. So this is really the basis for much of what you do in trig. You're going to use this so much. You're going to be dreaming of these values. I actually, when I took pre-calc in high school, best math teacher ever on the face of the planet, Miss Faison. But I was always amazed because she would put like a million of these problems on the board, and we would sit there and we would draw them and think about them. And, it took a while, and she would know the answer before anybody had even, she knew them all right off the top of her head. And I always thought, wow, this woman is such a genius. But I have learned that after you do so many of them and you teach it a million times, then they really stick in your brain very easily. So she was a genius, there is no doubt. But anyway, something I certainly remember that stands out in my brain from when I learned this the first time many, many moons ago. Okay, so our goal here today is to be able to evaluate a trig function, any of the 6 trig functions, at any of those angles of the special right triangles or a quadrantal angle that we talked about earlier in the previous video this week, okay? So the part that you need to remember, which is not the entire unit circle, right? Remember I said, please, please, please don't memorize the whole unit circle, even though I know some of you won't listen to me. Here's what we do need to know. So we need to remember 2 things. We need to remember where are things positive and negative, right? So in the first quadrant, we know every trig function is positive. Second is sine and cosecant. Third is tangent and cotangent. And fourth is cosine and secant. All right. And then I told you what else we need to remember are those 3 ordered pairs in the first quadrant. So all we need to remember is the first quadrant. So 30 degrees, remember, is equivalent to pi over which one? 6. And our ordered pair for 30 degrees is root 3 over 2, 1/2. 45 degrees is pi over 4. And our ordered pair is root 2 over 2, root 2 over 2. And then 60 degrees is pi over 6, which is 1/2 root 3 over 2. Okay, so stick this in your brain and memorize it. I hate to memorize, but we figured it out. We know where it came from. It makes logical sense, hopefully. But if you know this, you can use this to figure everything else out. Whenever I got a quiz or a test when I learned trig, this was what I wrote at the top of my paper. And once I had this, then I was good to go. I know some people always want to draw out the entire unit circle, which makes me crazy because it's just so much work and so much memorizing that you don't need to do. Okay, so let's do a couple examples and we'll talk about how we can use this in order to evaluate our trig functions. And then we're gonna solve some simple equations as well. Okay. So shall we start easy or hard? I love that question. I know you guys do too. How about middle of the road? So let's start with, okay, let's try I say easy middle of the road, but then I don't do that. This is not bad. Let's say we're going to find the tangent of 4 pi over 3. Okay, so if we want to find the tangent of 4 pi over 3, what we need to know is what's the reference angle, okay? The tangent of 4 pi over 3 is the same thing as the tangent of its reference angle, again, except for the sign, S-I-G-N, whether it's positive or negative, okay? So we're going to use this to tell us whether our answer is positive or negative. We're going to find the reference angle and use these to actually calculate the value, okay? So hopefully that makes some sense. All right, so let's start by figuring out where this angle terminates. So the tangent of 4 pi over 3, again, I don't care that it's tangent right now. I just want to know where does 4 pi over 3 terminate. So 4 pi over 3 terminates in which quadrant? So I know if standard position, this is 3 pi over 3, right? Since that's 1 pi. So we're going to go here and we will terminate in the 3rd quadrant, right? All right, so if our angle terminates in the 3rd quadrant, what do we know about tangent in the 3rd quadrant? Tangent is positive. So we know our answer is going to be positive, right? Obviously, we don't need a plus sign there, but that's just so we know that we did that part, and all we have to figure out is what the value is, okay? All right, now, what's our reference angle? Well, we know that our reference angle is formed with the terminal side and the x-axis, so we get an acute angle. So this is our reference angle, right? What is this reference angle? Well, if this was pi and the whole thing was 4 pi over 3, then this reference angle is pi over 3, right? Well, if we go to pi over, oops, I wrote that wrong, didn't I? Oops, daisies. You guys were yelling at me, but I couldn't hear you. So if we go to pi over 3 as our reference angle, we know that our tangent value, by definition, is y over x, right? So if we take y and divide by x, we get root 3 over 2 over 1/2. And if we divide those, then we are just left with root 3. So the tangent of 4 pi over 3 is just root 3. Super, wasn't that fun? Let's try another one, shall we? How about, let's try how about a sine? Let's find the sine. I know you all want to do degrees, but I really want our brains to really think in radians. Let's try the tangent of negative 5 pi over 6. Okay, so we're going to start by figuring out which quadrant we're in. So negative 5 pi over 6, we're going to rotate clockwise this time, right? So if we rotate clockwise, we're not a full pi, so we're going to terminate here, again, in the third quadrant. All right, what do we know about sine in the third quadrant? In the third quadrant, we know that sine is negative. All right, now let's figure out what our reference angle is. Our reference angle is pi over 6. So we're going to go to our ordered pair for pi over 6. We know by definition, sine is the y-coordinate of our ordered pair, right? So if sine is the y-coordinate of our ordered pair, then the sine would just be 1/2. And since it's in the third quadrant, we know it's negative 1/2. I guess that would be helpful information too, right? To remember that cosine of theta is x, sine of theta is y, tangent theta is y over x, and then you know they're reciprocals, right? So secant theta is 1 over x, cosecant theta is 1 over y, and cotangent theta is x over y. Oh, such good stuff. Okay, let's do 2 more maybe. I can't see if that makes sense to you, so I'm going to do 2 more and see where that takes us. How about, let's see, we've done tangent and sine. Let's try a secant. Let's try the secant of, what do we want to do? The secant of, how about, I know, look at me, right? You're all sitting there going, don't make it so hard, Mrs. Ondra. Let's try the secant of, let's try 17 pi over 6. Okay, so the secant of 17 pi over 6. So first we're going to figure out which quadrant we're in. So 12 pi over 6 is 1 full revolution, right? And that leaves us another 5 pi over 6, which is going to put us into the second quadrant. All right, in the second quadrant, what do we know about secant? We know that secant is negative. That was a large negative sign. All right, next, we need to know our reference angle. So here is our reference angle. If this was 5 pi over 6, then this is pi over 6. Hopefully you've seen the connection between the reference angles already. So what is the secant of pi over 6? Okay, so we're going to go to pi over 6, which is this ordered pair. We know secant is the reciprocal of which trig function? It is the reciprocal of cosine, and we know cosine is the x-coordinate. So we want the reciprocal of the x-coordinate. What is the reciprocal of root 3 over 2? Well, that would just be 2 over root 3, right? And then we want to rationalize, of course. Well, we probably don't want to, but we're going to. So we would end up with negative 2 root 3 over 3. Okay, I said 2 more, but I thought of 2 more that I want to do. All right, so that makes 3. Let's do something. Let's say we've got the cosine of, how about the cosine of 90 degrees? Okay, so where are we if our angle is 90 degrees. So where does that angle terminate? Well, 90 degrees is not going to terminate in any particular quadrant, right? 90 degrees is really right here. Okay, so that's what we consider a quadrantal angle because it doesn't terminate in a particular quadrant. It terminates on the axis itself. Okay, but these are actually really simple because we can just use some really basic knowledge. What's the ordered pair? So if we're on the unit circle, what is this ordered pair here at 90 degrees? Well, at 90 degrees, this ordered pair would be 0, 1, right? And we know by definition that the cosine of theta is which coordinate? It is the x-coordinate. So the cosine of 90 degrees is just 0. Does that make sense? Let's just think along the same lines. Let's continue that for a second. Let's say we wanted the sine of 90 degrees since we're here. The sine of 90 degrees, we know that sine by definition is the y-coordinate, right? What's the y-coordinate of that ordered pair? Is just 1. So the sine of 90 degrees would be 1. Here's something good to think about though. The reciprocal of sine is cosecant, right? So we know that, we know that the cosecant of 90 degrees is the reciprocal of 1, which is still just 1 as well, right? What happens though if we want the reciprocal of cosine? So what happens if we want the secant of 90 degrees? What is the secant of 90 degrees? Well, if we try and take the reciprocal of 0, what's 1 over 0? It is undefined, right? So there is no value for the secant of 90 degrees. So there are some trig functions that are not going to be defined. So which trig functions are going to be undefined? All 6 of them or just some of them? So clearly we can see secant is going to be undefined in some places. Same could be true for cosecant, right? If we were at a quadrantal angle here or here, then we would want 1 over y, which would be 1 over 0. So cosecant would be undefined. Is cosine ever undefined? No, because cosine is the x-coordinate, right? And if we move along our unit circle, we always have an x value. The same is true for sine, right? So there's always going to be a y value. What's the smallest value that sine and cosine could have? So if we're at the very, let's say we're thinking cosine. If we're at the very left of the unit circle, our cosine could have a value of -1, right? What's the largest value it could have? +1. So we know that the cosine of any angle has to fall between -1 and +1. How about the sine of theta? Also has to fall between -1 and +1. Okay, what about tangent and cotangent? Are they undefined at certain places? Sure, right? Because if we look at tangent and cotangent, tangent is y over x. Where will tangent be undefined then? Tangent's going to be undefined anytime x is 0 because we can't have 0 in the denominator. Where is cotangent going to be undefined? Anytime y is equal to 0 because we can't have a denominator of 0. Does that make sense? Hopefully, you're nodding your heads there. Okay, let's do one more of these and then we will solve some equations. So let's just do, let's say we want to find the cotangent of 315 degrees. Okay, so let's think about which quadrant we're in. 315 terminates in the 4th quadrant. What do we know about cotangent in the 4th quadrant? It is in fact negative. What is our reference angle? So our reference angle is 45 degrees. If we go to our ordered pair for 45 degrees, cotangent we know is x over y. So if we divide root 2 over 2 by root 2 over 2, we just end up with -1. Okay, so hopefully this makes sense. Obviously, I think the biggest thing here is that it just takes some practice. I did put lots and lots of extra practice for this on Schoology. So whatever you're in the mood to do, by all means, knock your socks off. And I did post the quiz for this as well, if you want to continue to practice. Time, I think, is important because you should be able to start thinking about them the more you do a little more quickly, okay? Okay, so let's solve a couple equations. And equations are essentially, we're just going in the opposite direction. So let's say, for example, that we wanted to determine we wanted to solve this equation. And we're going to solve this equation if theta is between 0 and 360 degrees. Okay, so we certainly don't have to have a restricted domain. That makes things a little bit more complicated. You will do that in pre-calc, so we're going to keep it simple for right now. This domain also just tells me that I want my answers, to be in degrees, since theta has to be between 0 degrees and 360 degrees. If it said between 0 and 2 pi, then I'd want to make sure to give my answer in radians, okay? All right, so what we're going to do is we're going to try and solve this. So where is cosine theta equal to 1/2? Well, we know that cosine is which coordinate? Cosine is the x coordinate. If I look at my ordered pairs, which ordered pair has an x coordinate of 1/2? All right, we're solving in degrees, so our angle would be 60 degrees, right? So that is my reference angle. Oops, I forgot to write it. Is the reference angle actually a solution? Well, sometimes it is and sometimes it isn't. In this case, is it? Sure, because the cosine of 60 degrees is positive 1/2. So one of my angles for theta would be 60 degrees. Is that the only angle in this domain that would satisfy that equation? Hopefully you are shaking your head. So we know that cosine is positive in the first quadrant, which is where 60 degrees is, but cosine is also positive in the fourth quadrant. So we need to find a fourth quadrant angle with a reference angle of 60, and that will give us our second answer. So if we think about this, if I have a reference angle, that's really bad, clearly not 60 degrees, a reference angle of 60 degrees in the fourth quadrant, what is the measure of this angle? Well, that would be 360 minus 60, so that would give me an angle of 300 degrees. That makes sense? Okay, let's try another one, shall we? Let's try, let's do a tangent. Let's say we want to solve tangent of theta equals -1. And then we'll do one in radians so that you can see that as well. Okay, so where is the tangent of theta equal to -1 is what we're trying to figure out. All right, so in order for tangent to be 1, since tangent is y over x, since tangent is y over x, the only way it can be equal to 1, again, we're not going to worry about the negative just yet, is if both x and y are the same, right? What's the only ordered pair where the x and y coordinates are the same? That would be our ordered pair of 45 degrees. So in this case, our reference angle is going to be 45 degrees. All right, is that reference angle a solution this time? It is not, right? Because 45 degrees is in the first quadrant, and the tangent in the first quadrant is positive, but we want our tangent value to be negative. So what we need to think is, where is tangent negative? In which two quadrants? So tangent is negative in the second and in the fourth, right? So if I have a reference angle of 45 degrees in the second quadrant, I need to know what is this angle. So if I subtract 45 from 180, that would give me an angle of 135. And now let's do the same thing in the fourth quadrant. So I need a reference angle of 45 degrees in the fourth quadrant. Again, remember your reference angle is always with the positive x-axis and the terminal side so that you get that acute angle. I need to know then, what is this angle? So if I do 360 minus 45, that gives me 315 degrees. Okay. Why didn't I just say -45 as an answer? Is that an answer for theta? Well, the reason it's not in this case is simply because of that restricted domain, right? So you certainly see that we could keep making rotations in either direction. So our angles could be positive or negative, and we could just keep going and going and going, right? But because I've restricted that domain, these two angles are the only solutions that we have, okay? Okay, let's do one more, and then that will be it. So let's change our domain this time so that theta has to be between 0 and 2 pi. And let's say we want to determine theta so that the cosecant of theta is -1/2. Okay, so our answers are going to be in radians. we want to know, where is cosecant theta equal to -1/2? Which angles theta will this be a true statement for? So I think when you're doing cosecant and secant, the easiest thing to do is to change those into its reciprocal sine or cosine, because it's a lot easier to just pick the x or y coordinate rather than having to try so hard. And how about I actually write the correct problem, because that's not going to work, is it? Let's make that a -2, sorry. Okay, so what's the reciprocal of cosecant? The reciprocal of cosecant is sine. So if cosecant is -2, then the sine of theta is -1/2, right? Okay, so let's start with our reference angle. Our reference angle has to be what? So where is sine equal to 1/2? Again, we're not worried about the negative. Sine is equal to 1/2 at which ordered pair? Which angle, I mean. We know that sine is the y coordinate, so that would be our top ordered pair here. So that means my reference angle is pi/6, again, because we're thinking in radians. All right, is pi/6 a solution? It is not, because we're in the first quadrant at pi/6, and the sign of pi/6 is not negative, right? It would be positive in the first quadrant. All right, so in which two quadrants is sine negative? Sine is negative in the third and the fourth. So if I have a reference angle of pi/6 in the third, that means this entire angle theta would be pi/6 plus pi, which is 7 pi/6. Just you see where I got that from. All right, what's my other value for theta? Well, I need a reference angle of pi/6 in the fourth quadrant, which means I need this whole angle. So what is this angle theta? So the whole revolution would be 2 pi, right? And if I subtract that reference angle of pi/6, that will give me that whole part that I want. So 2 pi minus pi/6 is 11 pi/6. So those would be my two solutions for theta in that particular domain. Okay, so a lot of information there. And again, I think it's going to take just a little bit of practice. So you have an assignment to work on. There's extra practice in the additional learning folder on Schoology. Let me know if you have questions, and have fun, because unit circle is great and math is fun. All right, hope you guys have a great day.